Do some problems from 7-5. All right, this factors, and if you forget how to factor something like this, you can type it into your calculator and graph it. You just graph that denominator. Let's see. Let's go out of polar into regular function. And looks like I got a bunch of things in here. Let's see if I got it. Oh, I think that's it right there. So I'll turn that one on, come down here, turn this off. And if I go zoom 6, and it looks like it does a bounce at -1, so that means x plus 1, it's x plus 1 squared, and it goes straight through at +1, so it means x minus 1 is a factor. Now, the factoring technique that you could use to get that is to say, okay, I can take an x squared out of these two, and that would leave an x plus 1. And then out of these two, I can take a -1, and that would leave an x plus 1. So in this term, there's an x plus 1, and in this term, there's an x plus 1. So I could factor those out. And I'd have x squared minus 1. And you should know that factors to x plus 1 and x minus 1. So we've got x plus 1 twice and an x minus 1. All right, to do partial fractions now. We have the x plus 1 or x minus 1 once, so I'll just say it's a over x minus 1. And the x plus 1 happens twice, so when we have that, we have to go x plus 1 with a b, and then an c over this quantity squared. Now we got to figure out a, b, and c. So this one needs the an x plus 1 squared times it. So x plus 1 squared is x squared plus 2x plus 1. Both numerator and denominator. And this one would need an x minus 1 and an x plus 1, which is x squared minus 1. And this one, to get the common denominator, would need an x minus 1. So just thinking of those for a moment and making sure that it's identically equal. If I look at the x squareds, there was no x squareds. So I would say 0 x squareds would have to equal ax squareds plus bx squareds. And looking at the x's, over here there were no x's. So 0 would have to equal, and this would be 2ax's. And here there's no x's, and here's an x. And then looking at the constants, there's a 1 here, 1 over all this, so I'd have to say 1 equals a minus b minus c. All right, so you could go to matrices on your calculator, do a 3x3 and type in 1, 1, 0, 2, 0, 1, and 1, minus 1, minus 1. Put this into b, 0, 0, 1, and do a inverse b. Matrix A inverse matrix B, and it would give you the A, B, and C. But this one's not too bad. If you add these two, we'll get something without a C in it. And we already have an equation, 0 equals A plus B. And these two added together would be 1 equals 3a minus b, and that would have no c's. These added together, and the b's would drop out, and I'd have 1 equals 4a. So a would have to equal 1/4. If a is 1/4, b would have to be negative 1/4. And if a is 1/4, this would be a half. So c would have to be negative 1/2. And so my original problem up here would turn into the integral. The a could come out. It would be 1/4 the integral of dx over x minus 1, plus the b could come out, so that'd be negative 1/4 the integral of 1 over x plus 1 dx. And then the c could come out, that's minus 1/2 the integral of 1 over x plus 1 squared dx. You could do u substitutions for all these, but since it's just 1x, and if you let u be that, du would be dx, and you'd have the integral of u, 1 over u, which is just ln. So this is 1/4 ln x minus 1 minus 1/4 ln of x plus 1. And this would be minus 1/2. So this, if we did the u substitution, would be 1 over u squared. So that's u to the minus 1 minus 2. So if you add 1, it'd be u to the minus 1 over minus 1 if you integrate it. So it's going to be 1 over, u to the minus 1 is 1 over this, so it'd be 1 over x plus 1 times the negative 1, which would change that to positive. And there would be our answer. Go ahead and do the substitution u equals x plus 1 if you didn't follow how I got that. You should be able to get that. All right, 30. Now this one's a good one to see because if we do long division, it makes this one pretty simple. So we're dividing this into this. So the numerator is always what goes inside the division sign. That's 3x squared minus 2 divided by x minus 4. So I start off by saying x times what makes 3x squared? Hopefully you say 3x times x is 3x squared. So I multiply that and I get the 3x squared. And I take the 3x times the minus 4 and get negative 12x. Draw the line and change the sign so I can add. These will cancel. And I'll get 12x minus 2. And x times what is 12x? So that's plus 12. 12 times this is 12x. 12 times negative 4 is negative 48. And I draw the line, change the sign, so I can add, and I get 46. And this degree is less than this, so then I stop and I put 46 over x minus 4. So this becomes the integral of 3x plus 12 plus 46 over x minus 4 dx. The integral of 3x is 3 halves x squared. The integral of 12 is 12x. And the integral, 46 could go on the outside, and we'd have the integral of 1 over x to the fourth, which would be 46 ln x minus 4, and that would be this plus c.